In this video, you are going to learn about measures of dispersion, examples of which include the concept of a range, an interquartile range, a standard deviation, a mean deviation, and we're also going to look at the variant of a distribution of data. So all of these apply to, a raw set of data, a collection of data, and measures of dispersion give you an idea of how stretched or squashed up the data is. So to put that in a different term, it tells you how varied the data is. It tells you whether all the numbers in that data set fall into a small range or they span a wide range. So it gives you that kind of idea. And the first thing we're going to look at is the range of a distribution, the range of a set of raw data. The statistical range of a set of numbers is given by the difference between the largest and the smallest number. So the range is equal to the largest number minus the smallest number. And we're going to take a look at an example. Take, for example, the following set of numbers. So this is just a set of numbers: 1, 2, 5, 6, 8, 25, 99. And I'll stop at 100. The range of this set of numbers is given by the largest number, which is 100, minus, so I'll just put that range of the above set of numbers is the largest number, which is 100, minus the smallest number. In this case, that's 1. So the range is equal to 99. Now, if I add, say, minus 2 to this set of numbers, the range will change because the smallest number has now changed. The smallest number is no longer 1, but now minus 2. So the range is going to be the largest number, which is still 100, minus the smallest number, which is now what? Minus 2. So 100 minus minus 2 is equal to 102. And that's the range of this new set. Next, we're going to look at another statistical property of a set of numbers or a set of data or a distribution of data, whichever way you want to put it. And it's known as the mean deviation. Now, what is a deviation? Let's take this number 10, for example. Now, on the number line, to the right of 10, you have numbers that are larger than 10. To the left of 10, you have numbers that are less than 10. So I'll just locate a number like 12 to the right of 10 and a number like 8 to the left of 10. Now, let's say 10 is our focal point, the point that we're measuring deviations from. You can say that 12 deviates from 10 by 2 units. And you can say 8 deviates from 10 by minus 2 units. You can kind of see the idea of a deviation. Deviation from some certain number. 12 deviates by plus 2, 8 deviates by minus 2. 12 is larger than 10 by 2 units, and 8 is less than 10 by 2 units. So that's the idea of a deviation. So now we're looking at the mean deviation, and in fact we're looking at the mean of the absolute deviations from the mean of a distribution or a set of data. Now, this is probably not going to make as much sense as it would when we do examples, but you need to be introduced to these subtle definitions and these formulas. So if you have a data set, so I'm calling the numbers in the data set X. So let's say we have things like 1, 2, 3, 4, and so on in our data set. I could say each number is X. X represents any number in this set. Now, the deviation we're interested in is the deviation from the mean, and I'll call that D. And D is given by that number minus the mean of the distribution, minus the mean of the data set. So the deviation of any number in the data set from the mean of the data set is given by that number minus the mean of the data set. Now, an appropriate notation for the deviation of a member of a data set from the mean of data set is something like this. Now, what does subscript I mean? I just simply refers to a particular number in the data set. So if X represents all the numbers in the data set, and I just say, okay, I'm going to label, in fact, I'll change these numbers. Make this 12, make this 5, 32, 41, 68. And I'll use this I to label each member of the data set. So I call this first member 1, this is the second member, this is the third, in fact I'll use that third, fourth member, and the fifth member. Now I tells you the member of the data set. So D1 tells you I'm referring to, well, X1 tells you I'm referring to X, the first X. And then D1 is the deviation corresponding to that X1, which is 12 in this case, minus the mean of the data set. So this formula also says D2 is equal to X2 minus the mean. So that means that the deviation of 25 from the mean is equal to 25 minus the mean. But I'm not using this notation to avoid overcomplicating, the whole lesson. So I'm just going to stick with something this simple, but you know that this means that the deviation of a particular member of a data set is equal to the value of that member minus the mean of the data set. So D refers to the deviation from the mean, M is the mean, which we've covered, and X the number or class mark, essentially a member of that data set. Class mark is something we use when we're dealing with group data. When we just have discrete data, we're just going to focus on the number. Now, the mean deviation is given by this formula, and I'll just write that down. It's given by the sum of this frequency times the magnitude of every deviation. So what you do is you get every number divided by the sum of the frequencies of the distribution. So what you do is you take if we're talking about discrete data, you take every member of the distribution, you find the deviation of each member, and for each member you multiply the magnitude of the deviation by the frequency, then you sum up all of these, and then you divide by the sum of the frequency. For group data, it's a similar process, except that instead of using each member, since you have group data, you're going to be using a class mark. Now we're going to treat this in examples, but I'm just introducing you to what we're going to be doing. Now, just in case you don't realize, the magnitude of a number is just the same thing as the absolute value of a number, and it's just the following concept. If you have a negative number like -2, its magnitude is 2. If you have a positive number like 2, its magnitude is 2. So to determine the magnitude of a number, all you have to do is ignore the sign. It's as simple as that. Now, this formula here for the mean deviation is the same thing as this formula here. The only difference between these two is that instead of writing the magnitude of deviation, I've written the magnitude of the deviation from the mean, which is the same thing as D. Remember, D is X minus M. So D has just been replaced with X minus M. So these two formulas are the same. This is just more explicit. Again, this formula is the same as this, but this applies when you're dealing with group data, because instead of using the members of the group X, you'll be using the class mark of each class in your distribution. This will make sense shortly, but this is what you need to know. The idea of the magnitude of a number, all you have to do is ignore the sign. You need to know that the deviation we're referring to is the deviation from the mean, which is given by this. But since we're interested in the mean of the absolute deviations, we then find the absolute values of each deviation, and that's where this comes in. And this whole expression here gives you the mean of the deviations, because each of these are deviations, and we're finding the mean of the deviations. So here's an example involving discrete data. It says the ages in years of 8 people waiting at a bus stop are 24, 25, 28, 30, 40 years, 50 years, 55 years, and 60 years. So these are the ages of 8 people. We're required to find the mean age and the mean deviation of the ages, which is the same thing as the mean of the absolute deviations of the ages from the mean of the distribution. But this is a short form of saying it, the mean deviation of the ages. So let's proceed. What are the ages? 24, 25, 28, 30, 40, 50, 55, 60. So I'm going to use this table to solve both questions. So I'm just going to write the ages in the first column. So I'm representing the ages with X, 24, 25, 28, 30, 40, 50, 55, and 60. So these are the ages in years. Ages in years. and f represents the frequency of each of these ages. If you remember from the ages we're given, there's just one of each. And the next column tells you product of the frequency and the age. And in our case, that's 1 times 24, which is 24, or the same thing as 24 times 1. It's 25 times 1. I mean, what you notice here is because all the frequencies are 1, the product of the frequency times the age is going to be the same thing as the age. 28 times 1 is 28. Anything times 1 is itself. So I'm just going to quickly fill out the remaining columns. Now we need to find the deviation for each, basically deviation of each member of, our data. So deviation of each age from the mean age. So d is equal to x minus m, or if you want, you can say di is equal to xi minus m. So in order to find d, you need to know x and you need to know m. We know x, we know all the x's, but we don't know the mean. So we need to find the mean of the ages, and that's what the first question wants us to find anyway. So the first question requires us to find the mean age. You need to find the mean, that's m. And the mean is given by, well, m is equal to sum of product, f times x, divided by the sum of all the frequencies. The sum of fx is given by the sum of all the numbers in this column. And if you do that with your calculator, so 24 plus 25 plus 28 plus 30 plus 40 plus 50 plus 55 plus 60, you will get 312. The sum of the frequencies is 8. 1 plus 1 plus, sum all the numbers in this column, or the number of ages, the number of members in our data set. And that's 8. So our mean is given by 312 divided by 8. Our mean is 39. So now that we know our mean, we can find the deviation of each member of our data set, of each age from the mean age. So the mean age is 39 years. So the deviation of each member of the data set is equal to the value of each member minus the mean. So the deviation of 24 from the mean is given by 24 minus 39, which is minus 15, which makes sense because 24 is less than 39. So 24 is less than the mean value, the mean age, by 15 units, hence the negative sign. The mean deviation from the mean of 25 is given by 25 minus 39, which is minus 14. Deviation of 28 from the mean is given by 28 minus 39, which gives minus 11. So for the other ages, I'm going to find the deviation by using this formula. And we're going to fill out the other columns quickly. This is something you can try at home to check if your table will match. 14 minus 39 is 1. 15 minus 39 is 11. 55 minus 39 is 16. 16 minus 39 is 21. Now I need to determine the magnitude of the deviations, the absolute value of each deviation, and that's just obtained by ignoring the signs. So minus 15, the absolute value of minus 15 is 15, absolute value of minus 14 is 14, and so on. So that's an easy column to fill. And finally, we need to multiply each frequency. We need to multiply each absolute deviation by the corresponding frequency. In this case, all the frequencies are 1. So f times the absolute value of the deviation is going to be the same thing as the absolute value of the deviation. So what I'm saying is 1 times 15. In this case, is 15. 1 times 14 is 14. 1 times 11 is 11, and so on. Now you're going to see why this table was structured this way, because to find the solution to question 2, the mean deviation, which is given by the mean deviation, which is given by the following formula. All we have to do is find the sum of this product, f times the absolute value of d, divided by the sum of the frequencies, which you already know. What's the sum of all the f by the absolute value of the deviation? Well, it's the sum of all the numbers in this column. So 15 plus 14 plus 11 plus 9 plus 1 plus 11 plus 16 plus 21 is equal to 98. Therefore, our mean deviation, which is this, is simply equal to 98 divided by the sum of the frequencies, 8, which is equal to 12.25 years. Here's another example, this time involving group data, and it says the scores of 50 students in a test are summarized in a given table. Determine 1. The mean score, and 2. The mean deviation of the scores. And here's the table. Here are the scores, and these are the classes. The first class has an interval from 0 to 99. The last class here has an interval of 600 to 699. And we have the corresponding frequencies for each class, or to each class rather. So what this is saying is that one person gets a score between 0 and 99 marks. 6 people got scores between 400 and 499 marks. Only one person got a score between 600 and 699 marks, and so on. And you know that the mean is given by, in this case for group data, the sum of this product here, where the product is the product of a class mark and the corresponding frequency divided by the sum of the frequencies. So we need this sum and the sum of the frequencies. The sum of the frequencies can easily be obtained by summing up all these frequencies, 1 plus 9 plus 10 plus 20 and so on, to give 50, or just by noting the fact that we're given the scores of 50 students, you know that the sum of the frequencies is 50. But it's always a good idea to sum it up from the tables, just to make sure the table you're going to be using to get your value has no mistakes. So the sum of the frequencies is 50. So we now need to determine the sum of fx prime, which is essentially the sum of this value. So we need to fill out this column and sum up all the numbers. So we need to determine the class mark x prime. So this is x prime. The class mark is given by the middle value of each class, or each class interval. The middle value for this class is given by 0 plus 99 divided by 2. Essentially, the class mark is determined by adding the lower class limit, the upper class limit, and dividing by 2. So 0 plus 99 over 2 gives 49.5. 100 plus 199 divided by 2 gives 149.5. 200 plus 299 divided by 2 gives 249.5. So I'll just do the same thing for the other columns. You just So we filled out the column for the class marks, and now we need to determine the product of a class mark and the frequency that corresponds to the class of the class mark. 49.5 times 1, or 1 times 49.5, 49.5. Just slightly reduce the thickness of the pen. 9 times 149.5 is 1345.5. 10 times 249.5 is equal to 2495. 20 times 349.5 is equal to 6990. So this is a bit laborious, and that's something you might get when you're facing a question requiring you to determine a mean deviation, or a mean in some cases. So 6 times 449.5 is 2697. So that's a 9. 3 times 549.5 is equal to 1648.5. 1648.5. And then 1 times 649.5 is simply 649.5. So now we have filled out this column, and to determine the sum of fx prime, we simply just add up all the numbers in this column. So the sum of fx prime, you're going to need a calculator for this. equal to sum of all these numbers, and when you do that on your calculator you get 15,875. The mean mark is given by 15,875 divided by sum of the frequencies, which is 50, and that is equal to 317.5, which is approximately 318 marks. So that's the average, the mean mark. So the deviation is obtained by subtracting our mean from each class mark. So essentially, each class mark minus the mean will give the deviation. This one by minus the mean will give its deviation from the mean. This class mark minus the mean will give its deviation from the mean. And we're going to use the exact value we got for the mean, not the approximate value. We're going to use 317.5 as our mean in the calculation to avoid losing accuracy at this stage. So 49.5 minus our mean, 49.5 minus 317.5 is equal to minus 268. It makes sense that it's a minus. The deviation is negative because 49.5 is actually smaller than the mean. What this tells us is that this class mark 49.5 is 268. It's 268 less than the mean, right? So for the next deviation, you subtract the mean from 149.5, and that gives minus 168. So I'm just going to fill out the remaining columns, and I'm just simply subtracting the mean from each class mark. So 249.5 minus the mean gives minus 68. 349.5 minus the mean gives 32. 449.5 minus the mean gives 132. 549.5 minus the mean gives 232, and 649.5 minus the mean gives 332. So to determine the magnitude of the deviation, so note, all this column is saying, this column is essentially deviation, which is the same thing as the class mark minus the mean. This column represents the absolute value of the deviations, the magnitude of the deviations, which is the same thing as the magnitude of this term, because x prime minus m is the deviation in this case. To determine the magnitude of the deviations, all you have to do is ignore the signs of the deviations. So this just gives 268, 168, 68, 32, 132, 232, 332. So now we need to determine product of each, the absolute value of the deviations by the corresponding frequencies. Why? Because the mean deviation is given by this. So in order to find the sum of f times the magnitude of each deviation, you need to find all the terms of all forms of this for each class. We need to determine f times the magnitude of each deviation, and then we need to sum each of them up. We need to sum all of them up to give the term in the numerator here. So all we have to do here is multiply the frequency that corresponds to each absolute deviation. So 1 times 268 is 268. 9 times 168. So I guess I will, just to make it clearer, I'll be circling them, right? So 1 times 268 is 268. 9 times 168 is 1512. 10 times 68 is 680. 20 times 32 is 640. 6 times 132 is 792. 3 times 232 is 696. 1 times 332 is 332. So to determine this numerator term here, we need to sum up all instances of this term here. So that's every member of this column. So that's 268 plus 1512 plus 680 plus 640 plus 792 plus 696 plus 332, which gives 4,920. Double check this value with your calculator. And now we can find the mean deviation, because the mean deviation is simply, I'll just write that again. So mean deviation, which is equal to this term divided by the sum of the frequencies, which is 50. And this is equal to 490 divided by 5. That's 98.4. So the mean deviation of the marks is 98.4 marks. And that's the mean of the absolute deviations of the marks, 98.4. Just simply using this formula. And if I go back to the original expression here, as you can see, the frequency times the absolute value of the deviations divided by the sum of the frequencies. These are just other forms of it. The one we actually used was this form here, where the absolute value of the deviation for group data is equal to the class mark minus the mean. So you need to learn all these formulas. They're all the same essentially. They're easy to remember. You need to know that the deviation of a member of a data set or a distribution from the mean is given by the value of that member minus the mean.